You know what happens when a total genius creates an absolute masterpiece, only to find a deep, fundamental flaw right at its heart? Well, that's pretty much what happened to Albert Einstein with his theory of general relativity. It sent him on this incredible quest to fix the very universe he had just described. So let me ask you a question, and it sounds simple, but I want you to really think about it. What is a particle? I mean, really, an electron, a proton, what are these things fundamentally? Because, see, back in 1935, Einstein and his colleague Nathan Rosen hit a major wall. They realized that general relativity, this beautiful, successful theory, couldn't actually describe a single particle of matter without its own equations just, well, breaking down. Now, to get why this was such a huge deal, you have to picture the world of physics back then. As Einstein and Rosen put it was far from being able to provide a unified foundation. Honestly, it was a house divided against itself. On one side, you had general relativity, and it was flawlessly describing the big stuff, the cosmic dance of planets and galaxies. And on the other side, you had quantum theory, which was just killing it at explaining the super weird world of atoms. Both theories were amazing in their own lane, but they just would not work together. And here's the real kicker. When you tried to use general relativity to describe a particle, the math would spit out this thing called a singularity. It's this point of infinite density where all the rules of physics just stop. Think of it like a division by zero error in the source code of the universe. And Einstein? Oh, he absolutely hated this. To him, a singularity wasn't some cool feature. It was a bug. As he put it in his 1935 paper, a singularity brings so much arbitrariness into the theory that it actually nullifies its laws. He was convinced any truly complete theory had to get rid of them. Period. So, what do? You're faced with this ugly flaw in your own beautiful creation. Well, what Einstein and Rosen did was propose one of the most elegant and frankly mind-bending solutions in the entire history of physics. What's so cool is how they did it. They didn't just throw everything out. No, they made this slight but totally brilliant change to the gravitational equations. They basically found a clever mathematical trick to rewrite the equations so they were free from denominators. It was this move that got rid of the infinities and let them completely reimagine the fabric of space itself. And the result of that one little fix was just, whoa, staggering. Their new equations didn't describe our one universe. Nope. They described a physical space made of two identical parallel sheets of spacetime. And here it is, the big reveal. In this new model, a particle isn't a point in spacetime anymore. As they wrote, a particle is now a bridge connecting these sheets. The particle literally is the connection. You have to understand this wasn't just a nifty trick. This was a complete redefinition of what a particle and reality itself could actually be. So let's just lay it out. On the left, you've got the old view. A particle is a singularity, a mathematical error, a flaw. But on the right, you have this new, beautiful view. A particle is a bridge, a natural geometric feature of spacetime itself. The problem had become the solution. And the power of this idea is that it solved a bunch of problems at once. First, it gets rid of those ugly singularities. It gives a reason for what they called the atomistic character of matter, like why matter comes in these neat little particle-like packets. And get this, it even explains why we don't see particles with negative mass. The math just showed that, quote, no bridge is possible that corresponds to a particle of negative mass. But they didn't just stop with one particle. Oh no, their vision was much, much bigger than that. They pictured a universe where you have two sheets of space-time connected by several discrete bridges. Just try to wrap your head around that for a second. Every single electron, every quark in your body is a tiny little tunnel connecting our sheet of spacetime to another, identical one right alongside it. And with this idea, they achieved one of Einstein's biggest dreams, a complete field theory. See, in this model, you don't need separate laws to tell particles how to move. The field equations themselves determine everything, both the field and the motion of the particles. The particle and the field were finally one and the same. So whatever happened to this incredible idea? Well, it kind of became an unfinished dream, but a dream with a really powerful and actually pretty famous legacy. Remember that bridge they proposed back in 1935? Today, we call that an Einstein-Rosen bridge, and it was the very first serious mathematical model of what we now call a wormhole. I mean, think about that. They weren't trying to invent a way to travel between stars. They were just trying to figure out what an electron is. Now, to be fair, Einstein and Rosen were the first to admit this was just a starting point. They had no idea if it could explain quantum stuff or if you could even have stable solutions for more than one bridge. The whole many-particle problem, they wrote, has not yet been treated. But that final sentence in their paper, man, it just sums up the sheer beauty of what they were trying to do. They believed they had found a path to a theory of matter that was logically completely satisfying and didn't need to invent any new, hypothetical stuff. It was all just gravity and electricity woven into the fabric of spacetime. And that kind of leaves us with a fascinating final thought, doesn't it? As physicists today are still struggling with that same great divide between relativity and quantum mechanics, you just have to wonder, could the key to it all be hidden in this elegant idea from almost 100 years ago? An idea that turned a simple particle into a bridge between universes?